common variance from all variables and they will put them into a common score. Now, how does this work practically? So all the common components are going to be put into one single system altogether. So once it reaches a particular value, then it will break even or break down kind of factor in terms of the pricing. Factor is less than 7, then we should not consider that factor at all. Good morning and welcome to the session 3 in unit 5 in business research methods, where we are going to talk about a very important topic called as the multivariate data analysis, which is going to talk about the factor analysis also. This is a very important topic because we are going to now understand how to do the multivariation analysis in statistics. And going further, the factor analysis is a technique that is being used to reduce a large number of variables into few number of factors. Now, this is quite interesting for all of us to know. Why? Because when we talk about this factor, when we talk about this method altogether, we want to bring in the consolidated data into a smaller segment, into a smaller sector altogether. So that's where I would always talk about this factor analysis method. In factor analysis, the most interesting part that you need to understand is that it is basically trying to reduce the whole lot of data into a small segment altogether, which is very useful for the analysis, for the method of analyzing things. Now, the next thing is that this technique will extract the maximum common variance from all variables and they will put them into a common score. Now, how does this work practically? Let's say that in a class, we are going to measure the variance among 40 students who are studying in a class for a particular subject. Then what we try to do here is that we will try to understand, analyze the common patterns among that 40 students and group them into a particular value or into a particular system altogether. So now what is happening is that those 40 students will have the common scoring pattern or a common variability factor altogether. So this will help us to reduce that 40 into one group where we consider that entire 40 as one lot which has the common characteristics. So that is where the factor analysis, so the common factors that brings this group together, that makes us understand their performance as one factor, is where we are using this factor analysis method. Moving further, let's further try to understand the next thing, which is going to talk about as an index of all variables, we can use the score for further analysis. Now, what is that further analysis? Factor analysis is a part of the general linear model, and this method also assumes several assumptions. Now, what are those assumptions? There is a linear relationship, no doubt about it. There is no multi-collinearity, so there is no multiple factors available there. It includes relevant variables into analysis, and there is a true correlation between the variables and factors. Now look into it. See, the way how it has been spoken about, the way it has been looked about altogether is that this will try to go in terms of understanding the general linear method, which also assumes several assumptions. So when we are doing a research, we are going to assume things and we are going to do in that particular manner. There is no multi-collinearity, so multiple factors are not going to become into it. It includes relevant variables into analysis. Yes, it has been understood that there are a lot of variables, a lot of analysis factor coming in, and there is true correlation between the variables and factors. So when I'm talking about a variable factor, correlation factor, yes, there is a relationship that is going to exist between them. Now, there are several methods available, no doubt about it. There are methods available for us, but there is the principal correlation method, which is very commonly used. Why? Because when we talk about the methodology that has been available, Though there are multiple methods, though there are multiple factors available, but what we are interested is known as the principal component analysis, which is generally used. Followed by the principal component analysis method is the most common method used by the researchers. It starts extracting the maximum variance and puts it into the first factor. As we told about the example, all the 40 students put in one single lot. So all the common components are going to be put into one single system altogether. After that, it will remove the variance explained by the first factors and then start extracting maximum variance from the second factor. So what we do is that first take the first lot of it, take the maximum variance, then take the second lot, take the maximum variance, third lot, fourth lot. So what we are doing, we are grouping all the variance factors together and we are trying to make it as a single group factor here. This process goes on till the last factor. So if there are 100 factors there, all the 100 factors would be listed inside. That is where this gets very, very interesting altogether. Why? Because this methodology is something that will try to understand, that will try to make you understand about the factors, how we are driving further in terms of the analysis, in terms of the factors. So every variance will be coupled and we will be joining it together in order to get the maximum variance factor done. Followed by the common factor analysis. The second most preferred method by researchers is that it extracts common variance and puts them into factors. So definitely it will put them into a common factor, a common understanding. And this method does not include unique variance of the variable. So we are not going to include any unique variance method because that is not there, that is being taught about, and this method is used even in structural equation modeling method. Now what is most important here is that when we talk about this factor analysis, since we are putting them into factor zone, we are clubbing them, we are putting them into a single factor here, this will not use a unique factor. We are not again going to go into the uniqueness of each and every one. Since we have clubbed it, since we have put it together, we are going to look it into a single joint factor alone. We are not going to separate it and re-look into it. This method is used in structural equation modeling. Why? Because this is one of the most important method through which you can arrive at a common equation when you are doing this modeling exercise. Followed by the image factoring, which is a very, very important technique that I would like to talk about. This method is based on correlation matrix. So when I use this word correlation, that means there's a relationship between two variables. So that's where the correlation matrix comes into picture. The OLS, the online squares method, the only linear square methodology, is also used to predict the factor in image factoring. When I talk about image factoring, I am going to look it from both sides. So how does it relate to another variable? So that is why this method is going to be used. Now, the maximum likelihood method, which is also very, very important. Why? Because this method works on correlation metric, no doubt about it, but it uses maximum likelihood to the factor. What is this maximum likelihood? Now, for example, if you are going to predict about a stock, or you are going to predict about an event to happen, we look for the maximum chances for that event to happen. Now let's look at it in the way of a stock market itself. Now, for example, I am going to predict the movement of a stock over a given period of time. So I know that in that given period of time, the stock movement has been consistent at a particular value. So once it reaches a particular value, then it will break even or break down kind of factor in terms of the pricing. So what I am trying to do here is that I am trying to maximize the entire chances, the maximum likelihood chances that it might fall down or it might go up. That's where I'm trying to understand this. That's where I'm trying to put it all together. So that is why I say that this method will matter a lot when we are going to talk about the likelihood chances. So this will try to understand what are the chances for a particular event to happen again and again in a given research methodology. Now, the other methods of factor analysis is the alpha factoring outweighs least squares method. So when we talk about the only least square methods or this factor, the alpha factoring will come into picture. Alpha factoring is a way where you are giving a priority based rating or a ranking to a particular variable, and then you will try to see how it is getting related, what are those factors that are governing there. So even this alpha factoring method is something that is very, very interesting for us to know. Why? Because that will give us quite a predictive analysis altogether. Now, we are also going to talk about the weight square, another regression base which is used for factoring. So you are now going to give weightage, priority to each and every one variable that is available there, and that weightage, that value will be considered as a very, very important factor. Why? Because when you go through the weightage, you will come to know what is the impact of one variable over the other variable. So when you give weightage, when you give the appropriate situation over one over the other, automatically that is going to be a very important analysis when it comes to factoring. Now, the factor loading. Factor loading is something which is basically a correlation coefficient for the variable and the factor. The factor handling or the factor loading shows that the variance is explainable by the variable factor on a particular method, and the same thing is used in the structural equation approach altogether as a rule of the thumb. Or it is, for example, if it is more than 0.7% more or a thumb high factor, it represents the factor extracts, saying that there is a sufficient variance from the variable. Suppose if it is below 0.7, then we don't see much of variance. But in case, as a rule of thumb, if it is more than 0.7, that is from 0 to 1, if it is weighing more than 0.7, that means there is a variation which is coming into picture, and we need to look out on that particular variation factor. Now, when we look into this, the factor loading is also a very, very interesting concept that is being used in the modern research. Why? Because of the correlation between a variable and factor. Now, there are many times in business where you would start seeing that there are so many variable components and so many fixed components. Now, because of a variation, there might be an effect on the production. Because of a variation, there might be an effect on the labor turnover. So, in those kind of business research, whenever you are speaking about, you would be likely to talk about the factor loading, where you are trying to prioritize certain values, you are trying to prioritize certain variable factors, and then take it forward. Now, the factor score, which is also called as the component score, very much onto this factor, because this is of all rows and columns, which can be used as an index of all variables and can be used for the further analysis. So that is also very, very interesting. Why? Because the factor score is also called as a component score. This is used for all rows and all columns, and this can be used as an index variable which is used for further analysis. We can standardize the score by multiplying a common term, which is definitely there. With this factor score, whatever analysis we do, we will be able to assume that all variables will behave as factor scores and move. So what we are trying to do here is that we are trying to standardize the entire pattern. So the factor score is like a component scoring method. So one component, let's say component C1. So that component has a weightage, say 50. This score is for all the rows and columns in that entire value, in that entire index. We will be going with this, and the variables can be used for the further analysis altogether. Now, when we are standardizing this value, the score, by multiplying with a common value, let's say I'm going to multiply this with 0.5. So whatever analysis is going to be done there, we will assume that all the variables will behave on the same factor score. So all the variables will have the same kind of scoring that we are going to talk about. Now, the criteria to determine the number of factors. One thing is the Kaiser criterion, which is coming into picture. eigenvalues are also good. Once these Kaiser criteria or the eigenvalues, these are all the statistical methods which have been used. We have standard terms and terminology in terms of determining the factor. Eigenvalues is greater than 1, then we need to consider that factor. If eigenvalues is less than 1, then we don't have to consider. Now, according to the extraction, as I've already told you, the variance factor is less than 7, then we should not consider that factor at all. If the variance is going more than 0.7, that means there's truly a variation and we need to consider it altogether. With that, I come to the conclusion of this particular session. I hope and believe that this session was of a great help and resource to you. In the upcoming sessions, we will talk more about the variance analysis. Until then, stay tuned, stay blessed, and stay enlightened forever. Thank you once again for joining me today on this wonderful session.